diode also gives the capacitance. What is the capacitor? The different plates, the parallel plates. Okay, so here also the anode ion, that is a acceptance and donor. Due to the two different plates, our capacitor, our diode also says a So how we are making the PN junction diode? How we are forming the, how we are constructing the PN junction diode? How? Taking the one semiconductor crystal layer, crystal bar. So on that we are diffusing the p-type semiconductor, on the other side n-type, that is a p-type impurity, that is a trivalent impurities and pentavalent impurity. That is the PN junction diode. Now coming to the transistor is having the 3 layers. Unlike a diode, the okay. Now here the transistors. In the diode, how the current is constituting, how the current is conducting. ఎలా వస్తుందమ్మ current in diode? Due to majority charge carriers, right? Due to the majority charge carriers, the diode is conducting, and the minority charge carriers also involving in the diode. Okay, that is in the reverse saturation current. Okay, now depending on the charge carriers, how many charge carriers are involving the current conduction, based on the two types. One is the unipolar transistors and bipolar transistor. The unipolar transistor means only if you are taking the p-type charge, what are the charge carriers are present in the p-type? P-type any charge carriers untai? Holes are majority charge carriers, electrons are minority charge carriers. Like in n-type also, the electrons are majority charge carriers, holes are minority charge carriers in the n-type semiconductor. Now, in that majority and minority, both are involving in the current conduction, then that is called the bipolar junctions. Bipolar. If the only one charge carriers are involving in the current conduction, those devices are called unipolar devices. Now the unipolar and bipolar, the main classification of the transistor is the bipolar, unipolar. Unipole means, uni means one, pole means polarity. So a single pole, that may be either majority, that is the electrons or holes, depending on the semiconductor we are using. If you are in the p-type semiconductor, only the holes are majority charge carriers. The holes can involve in the current conduction in the under unipolar. If you are in the n-type semiconductor, the electrons can involve in the current conduction in the unipolar. Coming to the bipolar, here the both charge carriers are involving, the minority as well as majority. That transistor is called bipolar transistor. So in this bipolar transistor, the one transistor that is the BJT, and here this transistor is called FET. The unipolar transistor is the FET. The FET stands for field effective transistor. The FET stands for field effective transistor, and BJT stands for bipolar junction transistor. Bipolar. The two polarities are involving the charge carriers. How the two polars involving the charge carriers? will understand in the construction and operation of the transistors. Okay. Now, here the BJT. Again, based on the which type of semiconductors we are using, based on the BJT are the two types. One is NPN transistor and the second one is the PNP transistor. The transistors are two types. There is a unipolar, bipolar. Under bipolar, again the two classifications. There is a NPN bipolar transistor and PNP bipolar junction transistor. Okay. Now, how we are constructing the transistor? How many materials are there in the NPN transistor? How many different semiconductors are there? Two different semiconductors, that is the N and P. And if you are taking the NPN transistor, the two N-type semiconductors, and if you are taking the P-type, PNP transistor, there is the two P-type semiconductors and one N-type semiconductor. Now, how the construction is transistor is constructing. The construction of the transistor is, allow name of it, NPN. Take the NPN transistor, the NPN, NP between N, P, N Madhyalo P. Okay, that is the NPN. That means the construction of the NPN transistor is the P-type semiconductor is sandwiched between two N-type semiconductors. The P-type semiconductor is sandwiched. This is the P-type semiconductor. This is the N-type and another N-type. So that is the sandwiched between the two semiconductors. That is called NPN transistor. So how we are making the NPN transistor? The one P-type semiconductor is sandwiched between the two N-type semiconductors is called NPN transistor. Similarly, you can think like bread, middle of jam. Jam is a P-type semiconductor. The two bread pieces are N-type semiconductor. So you can remember that. Bread, two bread pieces and a middle of jam. That is the NPN. So the jam is sandwiched between the two bread pieces. Here also the N-type and P-type is sandwiching. That is the construction of NPN transistor. And similarly, the PNP transistor, now the N-type semiconductor is sandwiched between the two P-type semiconductors. It's called the PNP transistor. Okay, so these two transistors are the bipolar transistor. So in these two transistors, the majority as well as the minority charge carriers are involving the current to conduction. Okay, now that is a construction definition. Now you can take the NPN transistor, Okay, so now the two and P-type semiconductor is sandwiched between the two N-type semiconductor. That is called the NPN transistor. Now the first region is the wider, the middle one is small, and the last one is moderate. Okay, so now first one, what are the majority charge carriers in the first region? Which type of semiconductor we are in the first region? N-type semiconductor. What are the charge carriers in the N-type semiconductors? Electrons, negative. The N-type semiconductor is having the charge, majority charge carrier. This is the, and the middle one is the P-type semiconductor. The P-type semiconductor is having the charge carriers are holes. Now the last one, N-type semiconductor, that is also electrons are majority charge carriers. Now the first one is the large width, means that is a heavily doped. The first region is heavily doped. The middle one is lightly doped. That's why that is having the less charge carriers. If the less charge carriers are, the area also less. The last one, moderately doped. Okay, last one is moderately doped. Now, without applying the any electrical field, here the N-type and P-type. Between the N-type and P-type, again, by sharing the electrons, donating the electron, accepting the electron, the junction will form. There is a barrier will form. That barrier we are calling a junction. Which junction? N and P junction, and P and N junction. So how many diodes are there in this construction? How many diodes are there? Two diodes. What are the two diodes? The one is this is the equivalent circuit using the diode symbol. The transistor using the diode symbol. Okay. Now here the charge carriers are electrons. And here also the charge carriers are electrons. And here immobile charge carriers, it is a positive ion, positive ion, positive ion, positive ion, and here negative, 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 and here negative, 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 and here hole, the majority charge carrier, hole, and here plus, 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 plus. Terminals. The base and the collector, that is the two PN junction. This diode is called emitter diode, and this diode is called collector diode. You can remember the words. The first, the junction between emitter and base is called the one PN junction. That PN junction we are calling as the emitter diode, the junction between emitter and base. Okay. Next, the junction between the collector and base is called another diode. That diode is called collector diode. The base is the common for the emitter diode and collector diodes. Now, the symbol of these transistors. Which transistor this one? Okay. Now, if you are applying after the construction, I will explain the symbol of the transistor. Okay. Now, if you want to note down, you can note down this. The transistor is the, note down, everyone. Transistor is the two types. One is the unipolar transistor and the bipolar transistor. Under bipolar, the NPN transistor and the PNP transistor. Bipolar transistor is called BJT. and unipolar transistor is called FET. And both transistors are the 3-terminal devices. Both unipolar and bipolar are the 3-terminal devices. The first one is the BJT. Again, the BJT is the 2 types, depending on the type of semiconductors we are using and arranging. Based on that, the 2 types of BJT transistors. One is NPN transistor and PNP transistor. The NPN is constructed by sandwiching the p-type semiconductor between the 2 n-type semiconductor is the n-type NPN transistor, and the PNP is the n-type semiconductor is sandwiched between the 2 p-type semiconductor is called PNP transistor. It's over. Okay, now operation of NPN transistor. The previous slide is the construction. Now, how that NPN is working. Okay, this is the n-type NPN transistor. Now that we are having the 2 junctions. For the 2 junctions, you can apply 2 batteries. One battery between the emitter and base, another battery between collector and base. Here you have to remember the one point. In the PN junction diode, if you are connecting the diode is in forward bias, that will give the forward characteristics depending on the battery connections. And here also, but here in that only the 1 diode, but here the 2 diode, there is a 2 junctions. So normal operation of the NPN or PNP transistors, you can write the PNP also. PNP. Emitter, base, collector. Okay, now while apply, this is called by connecting the battery, that is called the biasing. Biasing. Okay, so the biasing. So how we are applying the biasing to the 2 junctions? The first junction, the emitter base junction should be forward bias. Note down. While applying the biasing to the NPN or PNP transistor, the emitter base junction should be forward bias. Emitter base junction should be forward bias, and collector base junction should be reverse bias. Emitter base junction is forward bias, and collector base junction should be reverse bias. You can remember this point for applying the or connecting the battery to the NPN or PNP transistor. The emitter base junction should be forward bias, collector base junction should be reverse bias. This is for normal working of the transistor. normal operation of the transistor. Okay, so now connect the one battery here. Electrons. Okay, now what is the battery connection? Tell me. Connect the one battery here. What is the N type? What is the emitter terminal? What is the emitter terminal? Which type of semiconductor? N-type semiconductor. So N-type semiconductor is having the charge carriers or electrons, and here holes, and here electrons again. Okay. Now, if you want to get the forward bias for the emitter and base, this is the emitter and base junction. Okay. Now apply the negative term of the battery to emitter and positive term of the battery to base. And here this should be reverse bias. So here you can connect positive and negative. This is the biasing for the transistor. This is for the normal working of the transistor. And similarly, here also you can connect. Close button leda. Excuse me. emitter charge carriers. Total current is IE is equal to IB plus IC. The base current is the recombination of emitter and base charge carriers, and the collector current is the excess electrons of the emitter is collected by the collector terminal. So that gives the some current. That current is called collector current IC. So the current in the transistor is IE is equal to IC plus IB. And coming to this, here also same. In the PNP transistor, okay. See, the total current is IE is equal to IB plus IC. IB is the recombination of the base charge carries the emitter, and the IC is the excess after recombining the excess electrons from the emitter region or reaching the collector region. That constitutes a current. That current is collector current, IC. So the total current expression in the transistor is IE. The emitter current IE is equal to IB plus IC. Next, coming to the PNP transistor, the PNP, the first emitter region is the P-type semiconductor, and the collector also P-type, and the base is the N-type semiconductor. Now, according to that semiconductors, for the normal working operation of the transistor, you can connect the battery to the PN junction. That is the two diodes. That is the emitter base junction and the collector base junction. Okay, so now the emitter is the P-type semiconductor that is having the charge carriers or holes. Now we can, to keep the emitter base junction is the forward bias, connect the positive terminal of the battery to P-type semiconductor. Okay, that is the forward bias, and emitter collector is the N-type P-type semiconductor, that is the charge carriers or holes. And to keep the collector base junction in the reverse bias, you can connect the negative terminal of the battery to collector terminal. Okay, so now the transistor will operate. Okay, so which region is having the highest? This one. So that's why the current is moving from one region to another, transferring the high resistance to low. So that is called the transistor. So this is the working operation of the transistor. Note on the diagram. Yes. The both the NPN and PNP transistors connect the battery. Yes, hello. So how many terminals in the transistor? Yes. Respond. How many terminals in the transistor? 3 terminals. What are the 3 terminals? Everyone respond. How many terminals in the transistor? 3 terminals. What are the 3? Emitter, base, collector. Why the name is given to the first region as a emitter? Because it emitting the electrons. The total current constituted in the transistor is due to the charge carriers of emitter region only. The emitter is the highly doped, and base is lightly doped, and the collector is moderately doped. But the no electron of the collector is constituting a current, because the collector region is in the under reverse bias. Due to that reverse bias, the charge carriers of collector region are attracted by the battery. Okay, that is positive terminal or negative depending on the transistor we are type of transistor we are using. Okay. Now, in that PN junction diode, only one battery. Okay. Now, wherever you want the PN junction diode as a switch to control the flow of current, flow of electrons, you can use in that application, you can use the diode. But here, the transistor is having the three terminals. That is emitter, base, collector. Now, here, the emitter, base, collector, using these three terminals. Okay, first we'll go for the symbol. Transistor symbol. Okay, now apply the apply the bias voltage, that is the battery. This is, you can call it as a battery 1, battery 1, battery 2, right? Battery 1 and battery. Now, after connecting the battery 1 and battery 2, how the electrons are moving? Electrons in NPN transistor. What is the electron direction in the NPN transistor? From which region to which region the electron is moving? Emitter to collector region. The electrons are moving here. The emitter to collector. Now, then what is the current direction? Opposite. Right? That is, the current is flowing from collector to base, base to emitter. Right? That is the current is the always opposite the electron direction. So the electron is moving like this and the current is reverse direction. So the transistor is having the three symbols, the three terminals. The three terminals are and this terminal. So this is common terminal for the emitter and base. So that is called the base, and here the emitter and the collector. The three terminals. Okay, the transistor is having the three terminals: emitter, base, and collector. Right? Now we need to show the current direction. Based on the current direction, we are differentiating the NPN transistor symbol and PNP transistor symbol. So in the NPN transistor, how the current is flowing? From which region to which region? Base to emitter. Right? The base to emitter. So now we can show the current direction and the which region is constituting the whole current in the transistor? A region valla mana current vastundi. The which region or the which region charge carriers are constituting a current? Emitter. So on emitter terminal, you can show the arrow mark. The current is flowing from collector base to emitter. So this symbol is the NPN transistor symbol. Coming to the PNP transistor, the same symbol. Okay, this is the base, emitter, and collector. The three terminal. Now, in the NPN transistor, what is the current direction? From which region to which region the current is moving? Current endama. What is the direction? Current direction in the PNP transistor? విచ్ రీజియన్ నుంచి ఏ రీజియన్ లోకి ఏ రీజియన్ వెళ్తుంది? కలెక్టర్ టు ఎమిటర్, సారీ కలెక్టర్ టు ఎమిటర్ పోతుందా, ఎమిటర్ టు కలెక్టర్ పోతుందా? ఓకే, with respect to whole positive charge carrier, what is the current direction? With respect to whole, with respect to electron, there is the opposite direction. The current direction is opposite to the electron direction. Okay, but here there is no electron. The charge carriers are holes. Now, what is the current direction? The current direction is same as the hole direction. Now, the hole is moving from emitter to base, base to collector. Okay, so now the current direction is, here also the emitter is constituting a whole current, that is IE is equal to IC plus IB. So that's why the current symbol on emitter terminal only. So this arrow shows the current, conventional current direction. So the symbol of the NPN transistor as well as the PNP transistor. Note down. Transistor symbol NPN and PNP. Is it clear? The construction and operation of the transistor, how it is constituting a current, that is the operation. ఈ సర్కిల్ ఏంటంటే జస్ట్ సర్కిల్ రిప్రజెంట్ చేసినా చేయకుండా నో ఇష్యూ. సర్కిల్ రిప్రజెంట్ సింబల్ అంతే. సింబల్ మనం ఐడెంటిఫై చేయడానికి కోసం వీఆర్ షోయింగ్ ద, లైక్ వీఆర్ డ్రాయింగ్ ద circle. You can draw or no need to draw, nothing. Okay, so now the NPN and PNP are having the emitter, base and collector. Now this transistor we are using in electronic circuits. If the two terminals are there, connect the one circuit here and other circuit here, one end here and other end here. But here the three terminals are there. So out of these three terminals, the two terminals are acts as a input circuit, input terminals, and the other two acts as a output terminal. Input terminals are two. Okay, if you want to connect the battery also, positive terminal, negative terminal. Okay, and the output also same. So the input circuit is having the two terminals and the output also having the two terminals. But our transistor is having how many terminals? 3. So how we can make the 3 to 4 terminals? This input circuit amma 2 terminals untai, output to 2 terminals untai. But how many terminals in our transistor? Only 3 terminals. Okay. Transistor configuration. Next, put heading the transistor configurations. So in this transistor configurations, the two terminals acts as the input terminals and the two terminals acts as a output terminals. But for the input to output to, we require the total 4 terminals. But our transistor is having only the 3 terminals. So in these 3 terminals, the one terminal is the common for the input circuit and output circuit. The one terminal out of the 3 terminal, the one terminal is acts as a input common for the both, and the other 2 terminals, one is acts as a input terminal and other one is acting as a output terminal. One is the common. Based on the common terminal, the transistor configurations are 3 types. Now, which one you want to keep the common transistor now? Common terminal for the configuration. Which one you want to keep out of three? Base is the common terminal. Okay. If you are keeping the base is the common terminal. Okay. Now transistor configurations. You can draw the table. Configuration, name, input, output, common, and okay. If you are keeping the common terminal is the base. If you are keeping the common terminal is the base, then the input is the emitter terminal and the output is the collector terminal. That configuration name is called common base configuration. Right? The full name BCB stands for common base configuration. So the common terminal is the base and the input is the emitter and the output is the collector. Then that configuration is called common base configuration. And if you are keeping the emitter is the common terminal, if you are using the emitter is the common terminal, that configuration is called CE, common emitter configuration or CE configuration. Okay. So if you are keeping the emitter is the common terminal for the input circuit as well as the output circuit, then that configuration is common emitter configuration. So if you are keeping the common emitter configuration, what will be the input terminal and what will be the output terminal? Any guesses? Huh? What? Tell me. If you are keeping the emitter is the common for input and output circuits, then what will be the input terminal and what will be the output terminal? Input is C. Output is E. E already over. That is the emitter is the common for the input circuit and output circuit. Other two terminals are emitter, collector and base. So the base is the input terminal and the collector is the output terminal. And the last, the two terminals we are used as a common. And the other one is collector. Last one is the collector. That configuration is called common emitter configuration. Sorry, common collector configuration. So in this common collector configuration, the input terminal is base and output is emitter. Input is base and output is the collector, emitter terminal. So these are the three configurations. Note down. Yes. Okay, the three configurations, common emitter, common base, common collector configurations. Now, we are discussing the each configuration operation, the working operation. Okay, that is the common base configuration, common emitter configuration, and common collector configurations. The first one, the common base configuration. common base configuration. Now we can draw the transistor symbol in common emitter, common base configuration. This is the base common for input circuit, and here this is the input and this one is output. Okay, the transistor symbol. Okay, input circuit and output circuit. Next, which transistor? You can use the NPN transistor. The transistor type is NPN, and I will explain the NPN transistor. We can analyze the PNP. How we can analyze? In the NPN transistor, electrons are charge carriers. Wherever the electron is there, you can keep the hole, and wherever hole is there, you can keep the electron. Simply, the operation is the same. Okay, now, so this is the NPN transistor. Then you can take this. Emitter is, this is the emitter terminal, and this is the collector terminal, and this one is the base. Okay, this is the common base configuration. Okay, now in this common base configuration, we need to understand what are the input characteristics and what are the output characteristics. And in this common base configuration, the which junction acts as a input junction? Two junctions ఉన్నాయి అక్కడ. Emitter base junction and collector base junction. The which junction is acts as a input junction? Emitter. Emitter base junction is the input and collector base junction is output. Okay, now shall I draw the diode equivalent circuit for this? For the diode equivalent, I already drawn the first slide, that is this NPN. The transistor symbol using diodes, that is the common base, or simply NPN transistor. NPN transistor is the back-to-back connection of the two PN junction diodes gives the three-terminal device, that is the transistor. If anybody is asking how you can construct the transistor using two diodes, this the back-to-back connection of the two PN junction diode gives the three-terminal device, that is the transistor. That is the negative emitter, base, and collector. Always you can remember the emitter base junction should be forward bias and the collector base junction should be reverse bias. Okay. Now you can apply here biasing. Connect the biasing, connect the battery to keep the NPN transistor in the normal working operation. Connect the one battery to the input side and as well as the output side. Emma, take the two batteries, then connect the one battery here and the second battery here. Connect the batteries. Tell me, what is the diode directions? The battery directions. Emitter base junction, you can remember, emitter base junction should be forward bias and collector base junction should be reverse bias. This is midnight or late morning, you have to answer. For the normal working of the transistor, the emitter base junction should be forward bias and collector base junction should be reverse bias. Irrespective of the transistor configuration. Irrespective of the transistor configuration, connect the emitter base junction should be forward, collector base junction should be reverse. Okay, now what is the battery connection here? The emitter is the which type of emitter is which type of semiconductor? N type. NPN. NPN means emitter is N type, base is the P, and N is the collector. Okay, so now the emitter is the N type semiconductor. So N type semiconductor is having the charge carriers are electrons. So now to keep the emitter base junction is in the forward bias, connect the negative terminal of the battery to the emitter and positive terminal to base. Okay, next here MJ collector base junction should be reverse bias. So if the collector base junction is the reverse bias, then what is the battery connection here? P and this is the battery. Now, yes, now this is the CB configuration, the connections. Now we need to draw the VI characteristics. The NPN transistor, CB configuration, VI characteristics. Okay, so how many diodes are there here? The two diodes, there is the input diode as well as the output circuit. That is the output diode. Okay, for this, we'll get the two VI characteristics. That is the input characteristics and at the output side, output characteristics. Now here, you can remember the construction of the transistor. Right? Now, these are the all electrons. Yes, don't make noise. Okay, the two NPN N-type terminals, emitter, base, collector. Okay, now, yes, while to draw the VI characteristics for the input circuit, we need to keep the output parameters. What are the output parameters? Output current and output voltage. Output current and output voltage. What is the output current in the output circuit? The which terminal is connected to the output circuit? The current flowing in that terminal is called the output current. And the voltage is the voltage between output terminals. That is the base and collector. That is the output voltage. So the output voltage is the here. Here, the which current? The current flowing through this collector is called the output current. The voltage between the collector and the base, like here, is called the output voltage. That is the collector base voltage. And the current flowing in the input circuit, that is the input terminal emitter, that is called the input current IE, and the output current, input current IE, and input voltage is the emitter to base voltage. The voltage between the emitter to base is the input voltage. Now, for example, if you are applying the here, what is first, which characteristics I will explain? Input characteristics. Okay. So to find out the input characteristics, we need to keep the output circuit constant. Okay. So in that output circuit, the which parameter, there is a voltage or current, the which parameter is changing the transistor operation in the output circuit. Output lo ఏ పారామీటర్ ట్రాన్సిస్టర్ ఆపరేషన్ ని చేంజ్ చేస్తుంది. క్వశ్చన్ అర్థం కాల. To draw the input characteristics, the graph between the input current and input voltage. The graph between input voltage and output voltage, input voltage and input current. Input characteristics ni measure cheyadaniki which parameter in the output side we need to keep constant, or the which parameter is affecting the input characteristics. అది వోల్టేజా కరెంటా? voltage. The output voltage is changing the input characteristics. How it is changing? ఎలా చేంజ్ చేస్తుందమ్మా? Voltage is correct. The output voltage is changing the input characteristics. How? Anyone can answer? ఏది? ఓకే, without disturbing the input. Output కొద్దాం. Increase the voltage. If you are increasing the output voltage, that is the voltage between the battery connected between the collector and the base. The battery connected between the collector and the base, this one. Okay, if you are increasing this voltage, then what will happen in this base and emitter region, collector regions? Revert అదే మన అవుట్పుట్ బ్యాటరీ, ఈ బ్యాటరీ వోల్టేజ్ ఇంక్రీజ్ లో ఈ రీజన్ బేస్ రీజన్ లో వాట్ విల్ హ్యాపెన్? వాట్ ద చేంజెస్ విల్ హ్యాపెన్? ఏం చేంజెస్? what are the changes will happen in the output side, output circuit? There is an emitter and collector and base regions. Etla? Which biasing we are applying? Chargeeka transfer hotundi. Which biasing you can see? What is the biasing in between the collector and the base? What is the biasing here? Reverse bias. So if you are increasing the reverse bias, what will happen in the p-type and n-type semiconductors? There is a p-type, p region and n region. If you are increasing this voltage, what will happen in the collector region and what will happen in the base region? ఏమవుతుంది? రివర్స్ బయాస్ లో ఏమవుతుంది మామూలుగా జనరల్ గా? what is the operation of the reverse bias for the pn junction diode normal operation? Reverse bias pn junction diode కి అప్లై చేస్తే ఏమవుతుంది? what will happen in the diode? anyone? సౌండ్ వస్తుంది కానీ కరెక్ట్ ఆన్సర్ రావట్లేదు ఎవరి నుంచి. ఒక్కరి నుంచి వచ్చినా నేను క్యాచ్ చేసి స్టార్ట్ చేస్తాను. రివర్స్ బయాస్ లో వాట్ విల్ హ్యాపెన్ ఇన్ ద p type and n type semiconductors? No current. Okay, no current. Why no current? Repulsion. Due to the repulsion, repulsion వల్ల ఏమవుతుంది? కరెక్ట్. Because of the repulsion, that is the attraction of the battery terminals. Repulsion ఉండదు reverse bias. Attraction ఉంటుంది. Okay, what will happen in the reverse bias? If you are increasing the reverse bias voltage, అట్రాక్షన్ పెరుగుతుంది. అది ఇక్కడున్న ఎలక్ట్రాన్ ఇమ్మీడియట్ గా బ్యాటరీ దగ్గరికి వెళ్ళిపోతుంది. ఇక్కడ ఉన్నోడు పాజిటివ్ బ్యాటరీ దగ్గర ఇటు బ్యాటరీ దగ్గరికి వచ్చేస్తుంది. అప్పుడు ఏమవుతుంది? మధ్యలో ఏముంది? మధ్యలో బేస్ కాదు, జనరల్ గా చెప్తున్నాను. పిఎన్ జంక్షన్, యూ కెన్ రీకలెక్ట్ ద పిఎన్ జంక్షన్ డయోడ్ వర్కింగ్ ఆపరేషన్. ఒక పిఎన్ జంక్షన్ కన్స్ట్రక్షన్, ఒక సైడ్ పి మెటీరియల్, ఇంకో సైడ్ ఎన్ మెటీరియల్, మధ్యలో మనం బయాస్ అప్లై చేసాం, రివర్స్ బయాస్ అప్లై చేసాం. ఏమవుతుంది అప్పుడు? పిలో ఉన్న హోల్స్ బ్యాటరీ దగ్గరికి వస్తాయి, ఎన్ లో ఉన్న హోల్స్ ఎలక్ట్రాన్స్ బ్యాటరీ దగ్గరికి వచ్చాయి. మధ్యలో ఏమవుతుంది? గ్యాప్ వస్తుంది. ఏం గ్యాప్ అది? బ్యారియర్, potential barrier, junction width will increase. Okay, so if you are increasing the, listen carefully, if you are increasing the reverse bias, that is the reverse bias voltage between the collector and base junctions, the junction width increases, right? Junction width increases. Ekkada? Ikkada, idi. Here the junction width increases. Increase in a junction is moving to which region? There is a base or collector. Junction పెరుగుతుందమ్మా, జంక్షన్ విడ్త్ ఇంక్రీజ్ స్ప్రెడ్ అవుతుంది బికాస్ ఆఫ్ ద రివర్స్ బయాస్. అంటే బ్యారియర్ పెరుగుతుంది. ఆ పెరిగిన బ్యారియర్ ఏ రీజియన్ లో ఉంటుంది? ఈక్వల్ గా ఉంటుందా, డిఫరెంట్ గా ఉంటుందా? ఇది జనరల్ ఏమంటారు దాన్ని, కామన్ సెన్స్ యూజ్ చేస్తే వచ్చేస్తుంది. దీనికి టెక్నికల్ నాలెడ్జ్ అవసరం లేదు. కామన్ సెన్స్, యూ కెన్ యూజ్ ద కామన్ సెన్స్, యూ విల్ గెట్ ద ఆన్సర్. By applying the reverse bias, the junction width increases. That is the junction width, that is the junction between the collector and base will increase. That increased junction width is spreading into the collector and base equally or unequal. 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 So what is the unequal ratio? The which region, the depletion region will maximum spreading into the which region, and the low spreading to the which region? Maximum base. Why? అవును, మన ఇన్పుట్ ని డిస్టర్బ్ చేయట్లేదు, ఇన్పుట్ ని అట్లే పెట్టాం. ఫస్ట్ అవుట్పుట్ వల్ల మనకి ఏం చేంజెస్ ఫైండ్ అవుట్ చేసిన తర్వాత then we'll move to the input side, and then input will get the input characteristics. Okay, so now we are in the output circuit. I am increasing the reverse bias. Because of this reverse bias, the junction between the collector and base will increase. Increase అయినది ఏ రీజియన్ లో స్ప్రెడ్ అవుతుంది? Okay, listen. This is the emitter, base, collector. Okay, now we are keeping the emitter constant. Okay, this is the base. Which one is stronger in these two devices? Collector. Why? Because the doping ratio, the doping concentration is more with respect to base. Base kante ekwa, deen kante takwa, emitter kante. But so which one is stronger in these two devices? Collector is the stronger because the more charge carriers. In the soldiers are more, here very less. If the junction width is increases, which one is weaker? That increased junction is penetrating into that region. ఎవడు వీక్ ఉంటే అందులోకే కదా పోయేది. స్ట్రాంగ్ దగ్గరికి వెళ్తారా? బయట రోడ్ మీద వెళ్తుంటే ఎవరైనా స్ట్రాంగ్ ఉంటారు అనుకోండి, వాళ్ళ దగ్గరికి ఎవరు వెళ్ళారు. ఎవరైతే వీక్ ఉంటాడో వాడిని మరీ కావాలని ఏదో చేస్తుంటారు. సో అలా. సో ఇఫ్ ద జంక్షన్ విడ్త్ ఈజ్ ఇంక్రీజెస్, the increased junction width is penetrating into base. Now if the base width is increases, so sorry, the depletion region is, for example, intamma ide ila increase ayindi, and here only less amount. So now this. Now what is the resultant base width? Resultant base enta? What is the resultant base width? Is it increase or decrease? After increase, spreading in the depletion region into base, now what is the base width? Decrease. Okay. Now if the base width is decreases, what will happen? If you are increasing the input voltage, these electrons will cross easily to emitter to collector, because the base width is very, very less. తగ్గిపోయింది కదా region. The recombination rate also reduces, and easily the electron charge carriers will cross the collector region. Okay, that means the collector voltage is affecting the input characteristics. The the output voltage this output voltage, the voltage between the collector and base is affecting the input characteristics. So to draw the input characteristics, you can draw, keep the output voltage constant. So to draw the input characteristics, output voltage constant. What is the output voltage? Collector voltage between collector and base. Okay. Now, to draw the input characteristics, that is the voltage between current in the transistor. Now you can take the two measuring devices. One is the ammeter and voltmeter. Using the voltmeter, we are finding the voltage between the two terminals, and using the ammeter, the current in the device, current in the circuit. Now, generally, how we are connecting the ammeter in the circuit? Yes. How we are connecting the ammeter in the circuit? Parallel or series? Ela connect chestam? Series. The ammeter you can connect always series. The voltage, the voltmeter between the terminals. Where you want to measure the voltage, so connect the parallelly that voltmeter. Okay. So now to measure the input characteristics, you can connect one voltmeter. Yeah, this is the voltmeter. And here you can connect one ammeter. What is the current direction? Here, current direction is this. So here you can keep plus here, minus here, the ammeter direction. And next, what is the voltmeter directions? The voltmeter direction is same as battery direction by default. ఇక్కడ మీరు గుర్తుపెట్టుకోవాల్సింది ఓన్లీ బయాసింగ్. ఎట్లా మనం బ్యాటరీ కనెక్ట్ చేస్తాం అనేది ఇంపార్టెంట్. ఆఫ్టర్ దట్ యూ కెన్ కనెక్ట్ ద వన్ అమ్మీటర్ ఇన్ ద సిరీస్ అండ్ వోల్ట్మీటర్ ఇన్ ద ప్యారలల్. Voltmeter is same as the battery direction. So the battery is connected negative positive and voltmeter also negative positive. And ammeter, the positive is entry and the negative is leaving. So the positive and negative. And here also you can connect the one voltmeter. This voltmeter also positive, negative. This voltage is called VCB, collector base voltage, and this voltage is called emitter to base voltage, and this current is called IE. And here one more, here this direction plus minus, this is the IC, collector current. Now, which characteristics we are drawing? The input characteristics. Okay. Now, input characteristics. To get the input characteristics, oh, which parameter on the x-axis and which parameter on the y-axis? Huh? Same. The input characteristics always the voltage on y-axis, sorry, x-axis, current on y-axis, similar to PN junction diode characteristics. Okay. Now, to draw the input characteristics, you can keep output voltage constant. So how much voltage you want to keep constant? Output voltage 0 or 2 or 5? By default, first one, simply you can take 0. Okay. Now we are keeping the output voltage is the 0 volts first. VCB is equal to 0 volts. What are the changes in the junction? If you are connecting the 0 voltage to the collector and base, then what is the junction between the collector and base? Is there any changes or normal junction? Ideal junction? Emana change avutunda? No change, because the output voltage we are keeping constant. That is the 0 volts, right? Now, and we are not disturbing this part. This enta pettamu 0 volts పెట్టాం. How we are keeping these 0 volts? By adjusting this bias. By adjusting this bias voltage. Now you can keep the VCB is equal to 0. Now coming to the input bias here. Now you can vary this. ఇప్పుడు ఏమవుతుంది వేరీ చేస్తుంటే? వేరీ చేస్తుంటే ఏందమ్మా ఏమవుతుంది ఇందులో? Now we are increasing this slowly. First 0.1 volt. What will happen? Because of this negative terminal of the battery, these electrons are repelled. So the electron can move this direction slowly. That will not cross the junction because the junction is there. Now you can increase the voltage. So now you can increase the voltage at 0.3 volt. Now the electron will cross the junction. Okay. So now this. Yes. Okay. Now, so at the 0. So this curve for yes. Now we are applied the first case. VCB is equal to 0 volts. Right? Now, so we draw on the graph. If you are keeping the VCB is equal to 0 volts, that graph is similar to PN junction diode. The normal operation of the PN junction diode under forward bias. Because the input emitter base junction is forward bias. Now you can increase the reverse voltage. Now you can increase the reverse voltage, that is 2 volts. Increase the reverse voltage. After increasing the collector base voltage, the 2 volts, then what will happen in the junction? The junction width will increase. Right? The junction width will increase. Okay. That increased junction width is the most part can be spreading into the base and small, very small amount of portion into the collector region. Okay. Now, again, you can, yes, what's happening? Now, you can vary again this voltage from 0 onwards. Diode input characteristics, what will happen? If you are increasing this, so now we are keeping the collector base voltage the 2 volts. By making the collector base voltage the 2 volts, the junction width is increases. That increased junction width is penetrating into base region. Now the resultant length of the base can be reduced. The resultant base width will reduce. Okay. Now we are increasing the input bias. Then what will happen? At what voltage? There is the E curve kanna mundu ostunda, E curve tarvata ostunda. When the diode will start conduction. ఎప్పుడు కర్వ్ ఎక్కడ వస్తుంది? The curve will be this side or that side. అది ఎర్లీగా కండక్ట్ అవుతుందా, లేట్గా కండక్ట్ అవుతుందా? Compared to the previous voltage, now it will conduct early because the diode is, the base width is reduced. So now the electron can cross easily from the emitter to base and base to collector because of the base is having the more electrons. The emitter is having the more charge carriers. Okay, yes. Now, see here. Now, if you are increasing this bias voltage, the electron can cross easily from here to here. So now this will start conduction early. So that is 2 volts. Okay. So are you understanding? అర్థమవుతుందా? Why you are making noise? Okay, see, if you are increasing the reverse voltage, the junction with reverse junction will increase. Increase in మొత్తం దీనిలోకి వచ్చేస్తుంది బేస్ లోకి. So the emitter charge carriers will move early to the collector region. Okay, so that's why the input characteristics will conduct early. తగ్గాను అది కూడా పోయింది స్క్రీన్ పోయింది. Okay, now still if you are increasing here 5 volts, then what will happen? Again the junction width increases. Okay, if you are increasing this, it's okay. Yes, hello. Okay, now you can connect same input characteristics. Yes, now you can keep the output voltage 5 volts. Now you can keep the output voltage 5 volts. If you are increasing the output voltage, the reverse bias, the output junction will increase. The output junction, that is the base between the collector and base, will increase. So that increased base width is penetrating the base. The increased junction is the reverse junction width is penetrating the base. Now the base resultant area will become reduced. Here this area will reduce. Okay, this is the actual area. Yellow color is the actual area. Now this is the depletion region. That increased depletion region, the most of the part is penetrating the base. Now the resultant base width is reduced. Now if you are increasing this voltage, then what will happen? It will start conduction early. It will start conduction early. That is, here the VCB is equal to 4 volts. This is the VEB. Okay, so VCB is equal to 4 volts. It starts conduction early. This effect is called the early modulation. The early modulation or early effect, that is the base width modulation. So if you are increasing the reverse bias voltage, the junction between collector and base will increase. That increased junction is penetrating to the base. The resultant base width will reduce. Now, if you are varying the input bias voltage, the bias, now the transistor will affect early, response early. That effect is called the early effect or the base width modulation. This is the 2 mark or 1 mark question in the competitive exams. What is the early effect or base width modulation? The base width modulation means if you are increasing the reverse bias voltage, there is a reverse voltage between the collector and base, the junction width increases. The increased junction width is penetrating to the base. And now if you are varying the input voltage, this voltage, then the transistor starts conduction early. So that effect is called the early effect or the base width modulation. Okay, no doubt. The NPN input characteristics. To draw the input characteristics, we are keeping the output voltage constant. Everyone draw the circuit. మీరే చేస్తుండది ఎవరు చేస్తున్నది దాన్ని డిస్టర్బ్ చేసేది ఎవరు ఆఫ్ చేయాలా లేరు ఆయన వెళ్ళిపోయాడు okay next so how we are drawing the input characteristics what is the procedure to draw the input characteristics yes boys what is the procedure to draw the input characteristics the first step apply the biasing for the input diode and the input circuit and output circuit apply the bias between the emitter and base and the collector and base okay under CB configuration now to draw the input characteristics keep the output voltage constant at fixed voltage now come to the input circuit now you can vary the input bias this one right now you can vary the input circuit and note down the voltage in the input voltmeter and current in the ammeter. So here the note down this ammeter current and voltmeter current, voltmeter voltage, and you can draw the and you can vary the different steps of this bias voltage. Different steps you can vary, and for the each step you can note down the voltmeter and ammeter readings. Now you can draw the graph. So you will get the graph like this. That is the first step. Now come to the again you can vary the output voltage. So in the previous case, you are kept the constant. Now you can increase the output voltage. That is 0 to 2 volts. If you are increasing the 2 volts, the reverse bias junction will increases. Okay. Now, because of that, the base width will reduce. Now you can vary the input voltage. Now note down the input voltmeter voltage and the input ammeter current. Now you can draw the graph. You will get the graph like this. So here, this is the 0 volts graph. For the 0 output voltage, the graph is this one. And for the output voltage, the 2 volts, the graph is this. So compared to the 0 volts of the output voltage and the 2 volts of the output voltage, the 2 volts curve is starting early. That effect is called the base width modulation. Base width modulation because of the base width is modifying. Why the base width is modifying? Because of the depletion region is penetrating into the base region. So the base width will reduce. So because of that, the input characteristics will start early. That effect is called the early effect or the base width modulation. Now come to the output characteristics. See, now to draw the output characteristics, what is the graph between collector base terminal voltage and collector current? Right? The collector current and collector to base voltage are the output parameters. Okay. Now you can draw the graph between here output voltage, the collector to base, and output current IC. Okay. Now anyone can tell me, to draw the output characteristics, we need to keep the input circuit constant. Constant means without. Emitter current and so in these two parameters, the which one is affecting the output characteristics? The which parameter is changing the output characteristics? See the diagram. Current or voltage? Input voltage constant betala, input current constant betala. To get the output characteristics. Huh? Input current. Correct. The input current we need to keep constant. Why? Input current we need to keep constant. Why not voltage? Voltage effect cheyateda output characteristics ni. Okay. If you are applying the input voltage, that is the emitter base voltage, what will happen? There is a positive bias. Why you are keeping the biasing? To keep the forward or reverse. Okay. If the diode is forward bias, then what will next? If you are increasing also forward bias. The low voltage also forward bias. Okay. So the voltage is not affecting the output characteristics. So which parameter we need to keep constant? Current. Why the current? Because if you are applying the more current is flowing from the emitter to collector, the more current will happen. More current will get in the output characteristics. What is the current expression? IE is equal to IC plus IB. Okay, so the input current we need to keep constant. Now we can keep. So here we are keeping as input current. To draw the output characteristics, the input current keep constant. right? So now you can keep, yes, keep the input current constant. Okay. Now first, what is the input current in the circuit? What is the input current? What is the parameter? Input parameter. ఏంటమ్మా? What is the input current? ఏంటి input current? IE. Emitter current is the input current. So now you can keep emitter current constant. Okay, so the input current, that is emitter current, you can keep constant. First enta pedtaramma? 0 amps. 0 amps. Or you can keep the 2 milliamps. Okay, now the input current is the 2 milliamps. Listen carefully. Here the input current is the 2 milliamps I am keeping. Now I am varying the output bias this. The battery between the base and the collector is connected. That battery we are varying. Now, what is the voltage in the base and the collector regions? What is the voltage in the collector and base junction? 0. See, the which region is constituting the whole current in the transistor? Which region is constituting the whole current in the transistor? Yes. The which region is emitting the charge carriers? Emitter. So now that emitter we are keeping constant. Ante kada? 2 millivolts దగ్గర పెట్టాను. 2 milliamps దగ్గర constant పెట్టాను. So how much current will be present in the output circuit? 2 milliamps only. Now if you are increasing the reverse voltage, this voltage, then what will happen? What is the current in the output? Increase or decrease? Decrease అవుతుందా? Why? No change. What is the current expression? IE is equal to IC plus IB. If you are keeping IE is equal to 2, so what will be the current in the output junction? 2 milliamps. Okay, so if you are increasing this bias voltage, if you are increasing this, ఒకటే అమ్మా, ఇక్కడ నుంచి ఇక్కడ ఎంత ఇస్తున్నారు మీరు? 2 milliamps ఇచ్చారు, right? We are giving the 2 milliamps from emitter to collector. Now if you are varying this terminal, then the 2 milliamps only present here, because we are not varying this. This is a constant, we are keeping constant. So the no electron beyond this 2 milliamps, the no electron will cross, because we are not varying this terminal voltage. Okay, so that gives the graph like this. That is, this curve for IE is equal to 2 milliamps. Yes, hello. Next, you can keep this current is 5 milliamps. Now, what will be the output current? See, you can see here, if you are increasing the voltage, reverse voltage, the output current is the constant, because the input we are keeping constant. The input current only will present in the output circuit also, because the emitter only will constituting a whole current. Now we are keeping the emitter carriers are constant at 2 milliamps. So if you are keeping the input current is the constant, the same current will be present in the output circuit if you are increasing the output voltage also. So because of that, the curve gives, see here, this curve. The only if you are increasing the voltage, but the current is constant. What is the constant value? 2 milliamps. less than 2 milliamp because of that reverse bias junction also. Okay, but that gives the constant current. Now you can increase the reverse bias, the input current by varying this bias. By varying this bias, you can increase the input current 5 milliamps. So what is the output current now? That is also now 5 milliamps in the output circuit. That is also constant by increasing the collector base voltage. Okay, now the curve. Right? So now this is equal to 5 milliamps. If you are increasing the IE is equal to 50 milliamps, you will get the collector current also 50 milliamps constant. 50 milliamps or less than 50 milliamps only, that will give the constant current. Okay. So now, so these are the output characteristics. Right. Now, you can summarize this common base configuration characteristics to draw the input characteristics. The which parameter we are keeping constant? To draw the input characteristics, the which parameter we are keeping the constant? Output voltage. Yes. To draw the input characteristics, we are keeping the output voltage is constant. And then we are drawing the graph between the input voltage and input current. And coming to the output characteristics, to draw the output characteristics, ఇంతమంది ఉన్నారు మార్నింగ్ నుంచి అదే చెప్తున్నాం బ్యాటరీ 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 ఫార్వర్డ్ రివర్స్ ఫార్వర్డ్ రివర్స్ ఫార్వర్డ్ రివర్స్ what is the base terminal which type of base is the p type semiconductor so the junction between the emitter and base should be always forward bias so the forward bias ఉండాలంటే ఏం చేయాలి emitter is the negative so the negative you can connect to the here and positive here the voltmeter you can keep the same direction positive negative and here collector and base collector and emitter so emitter లేదు ఇక్కడ collector you can remember so collector should be reverse so what is the collector terminal n type semiconductor so you can connect here p positive and negative so here the positive and negative right the positive and negatives okay this is the common emitter configuration circuit diagram we'll understand the common emitter input characteristics and common emitter output characteristics we'll understand we'll discuss tomorrow now if you are having any doubt you can ask me if you are no doubt then I will ask the questions yeah anyone is having the doubt kindly raise I will come to you then you will ask the question yes boys sit down okay yes okay I'll start the questions question answer session what is the first electronic device what is the first electronic device huh I am asking the not application electronic device component electronic device the first electronic device is the vacuum tube that is invented in 1904 so who invented the vacuum tube John Fleming so that is also that vacuum tube is also called thermionic diode that vacuum is also called thermionic diode okay next what is the when the transistor is invented transistor or 1947 who invented the transistor the three scientists Bardeen Brattain and Shockley the three authors the three scientists invented the transistor before that after the vacuum tube one more device is there that is the triode the triode is invented by Lee D Forest okay who used the word nanotechnology word ever use చేశారు first yes 1952 in 1952 the IC technology term was used term use చేశారు okay the nanotechnology concept was introduced in 1952 and after 1974 the IC technology was invented and patented okay so that is the evolution of electronics and what are the types of semiconductors two types what are the two types intrinsic and extrinsic pure and impure what are the pure semiconductors all fourth group elements are pure semiconductors and the extrinsic how you are getting the extrinsic semiconductors by adding by doing the doping. By doing the doping, we are getting the impure semiconductor, that is the extrinsic semiconductors, to increase the conductivity of the semiconductors. So what is the use of doping? To improve the conductivity of the semiconductors. So that's why we are adding the doping. What is the doping? Adding impurity to the pure semiconductors. What are the impurities? Pentavalent, trivalent. Pentavalent and trivalent. The third group elements are trivalent and fifth group elements are pentavalent. If you are in the pentavalent, that is the N-type semiconductor. If you are in the trivalent, that is a P-type semiconductor. Okay, that is called P-type semiconductor and N-type semiconductor. So in the N-type semiconductor, what are the charge carriers? What are the charge carriers in the N-type semiconductor? Electrons are the charge carriers. That is a majority charge carrier. What are the minority charge carriers? Holes are minority charge carriers in the N-type semiconductor. And similarly, P-type semiconductors, holes are majority charge carriers. And electrons are minority charge carriers. Okay. Now, so in the PN junction diode, what are the immobile charge carriers? Immobile. Mobile charge carriers are electron and holes, depending on the semiconductor. Mobile charge carrier ante P-type lo hole, N-type lo electron. What is the immobile charge carrier? Immobile charge carrier. Ions. There is the acceptor ions and donor ions. Because of this acceptor and donor ions, the junction, the barrier is forming. That barrier we are calling as junction. Okay. Now, what is the knee voltage of silicon diode? Knee voltage or cut-in voltage? The 0.3 volts for germanium, because the germanium atomic number is the large. And the large unde and the neutron power danni takku untadi. Okay, so that's why the cut-in voltage of the germanium is 0.3 and cut-in voltage of the silicon diode is 0.7 volt. Okay, now what is the difference between the PN junction and GNR diode? Only the one difference: high concentration of doping in the GNR diode. Because of that high concentration, the GNR diode can conduct in the reverse bias also. But at certain voltage, the diode will give the maximum current. Further, the voltage it will not increase across the diode. That voltage is called GNR diode. That voltage range is the morning the point to the GNR voltage range is 3 volts to 200 volts. 3 volts to 200 volts. The 3 volts to 200 volts depending on the manufacturing of the GNR diode. How much doping we are adding? Dani batti adi vary avutunde 3 to 200 volts. So because of the GNR voltage, the GNR diode acts as a regulator, voltage regulator. Regulator ante regulate chestadi. Constant value nu output istundi. Okay, that is a GNR regulator. GNR as a voltage regulator. Coming to the PN transistors, the diodes are the two terminals, that is the anode, cathode. And the diode name is the two ions are present. Because of that, we are calling the diode is the diode. Di-2. Ion, two ions. Iode means the two ions, diode. Coming to the transistor, this transferring the current from high resistance region to low resistance region. High resistance region to low resistance region. Ela avutundamma? Anyone can tell me? Meeku indaka working operation cheppanu kada. Transistor emannanu, it will pass the current from high resistance region to high resistance region to low resistance region. Meeku PNP transistor lo gaani NPN transistor ekkada resistance ekku undi, ekkada takku undi? In which region is the high resistance? In which region is the low resistance? Emitter is having the less resistance because of the more charge carriers. Because there is a forward bias. Emitter base junction is forward bias. Forward antene less resistance. And diode and collector base junction is the reverse bias. more resistance. What is the current direction? Base to emitter. ఎక్కడి నుంచి flow అవుతుంది current? Collector to emitter. Right? What is the collector? High resistance region. Emitter is low resistance. So the current is transferring from high resistance region to low resistance region. That's why the transistor is called the transferring the resistance. Okay, that is transistor. And the transistor is having the three terminals: emitter, base, collector. Emitter, base, collector. Why the names also? Why we are giving the particular names? We already discussed. There is the emitter, emitting. Base is so like acts as a bridge లాగా మధ్యలో, అంటే దానికి దీనికి కనెక్టివిటీ చేస్తుంది. దేనికి? ఎమిటర్ నుంచి కలెక్టర్ కి. అంటే ఎమిటర్ ఎలక్ట్రాన్స్ ఎమిటర్ నుంచి కలెక్టర్ రావడానికి మధ్యలో బ్రిడ్జ్ గా అది వర్క్ అవుతుంది. సో దట్స్ వై ద నేమ్ ఈస్ బేస్. అండ్ కలెక్టర్ కలెక్టింగ్ ద ఆల్ ద చార్జ్ క్యారియర్స్ ఆఫ్ ద ఎమిటర్. ఓకే, నౌ దట్ క్రాసింగ్ the 100% of electrons in the n type, that is the emitter. In that 100%, the 2 to 5% of electrons are recombined with the base charge carriers. Because of that region, the base will constitute a current. That current we are calling as the base current IB. And the remaining 95 to 98%, 2 to 5 anana, akkada 98 to 95 to 98% of electrons are crossing the junction. That constitute a current. That current is called collector current. Okay, so now the total current constituted due to the charge carriers of emitter only. That is emitter equal to IE is equal to IC plus IB. ఇంతవరకు వచ్చింది కానీ మనకి ఎక్కడ రివర్స్ సాచురేషన్ కరెంట్ అని ఎక్కడ వచ్చిందా? వాట్ ఇస్ ద ట్రాన్సిస్టర్? ఇస్ ద బైపోలార్ ఆర్ యూనిపోలార్? బైపోలార్ ట్రాన్సిస్టర్. బైపోలార్ అంటే టూ పొలారిటీస్ ఆర్ ఇన్వాల్వింగ్. మీకు కలెక్టర్ ఏ బయాస్ లో ఉంది? కలెక్టర్ బేస్ జంక్షన్ రివర్స్ బయాస్. సో కలెక్టర్ రివర్స్ బయాస్ ఉన్నప్పుడు అక్కడ మీరు కలెక్టర్ ని ఇంక్రీజ్ చేశారనుకోండి, కలెక్టర్ వోల్టేజ్ ఏమవుతుంది? హీట్ అవుతుంది కదా జంక్షన్. డ్యూ టు దట్ హీట్ అగైన్ కోవలెంట్ బాండ్స్. నౌ ద కరెంట్ ఎక్స్ప్రెషన్, యాక్చువల్ కరెంట్ ఎక్స్ప్రెషన్ ఈస్ the IE is equal to IC plus IC naught. IB is negligible. The base current is negligible. That is a very, very less. Now the total current is the E is equal to collector current plus the reverse saturation current of the collector region, because the collector, this is the reverse bias. That reverse bias also will constitute a current. That current is called reverse saturation current. That current is called the reverse saturation current. Okay, now because of the three terminals in the transistor, we are dividing that transistor into the three configurations. Based on the common terminal, we are dividing the configuration of three types: common base, common emitter, common collector. If the base is the common, that is the common base. Emitter is the common for the input and outputs, that is the common emitter. And the collector is the common, then that is called the common collector configurations. Okay, so now the next we will discuss the common emitter configuration characteristics. Once again, you can read these notes in the evening. Okay, and come prepared by these topics. If you are understanding this concept, the next sessions will be understand clearly. Okay, if you are having any doubt, you can ask me, or you can wait. Those who are having the doubts, you can wait here. Others you can leave.